This is the second part of the 3.3 notes for pre-calculus on properties of logs. We're looking to condense this logarithm. So the first thing is I know that these numbers out front are going to turn into exponents. And with this plus sign, I know that these two different logs are going to be combined together. They're going to multiply. So this is the log of x to the fifth plus the log of 5 to the third. 5 to the third power is 125. And to get these into one log together, again, the plus sign means to multiply, so it's log of 125 x to the fifth minus, and then if we condense these together, this 6 becomes an exponent. The plus means these are going to be multiplied together on the inside, so we'll go with log of z plus the log of, and 2 to the 6th power is 64. And one more time, combining those together, it's going to be the log of 64z. So we have everything done inside of the different parentheses. Now to combine them together into just one single log, this minus sign means we're going to divide what's inside of those logs. So now we have it totally condensed, and here is our answer. Here's the next problem. Maybe you want to try to pause the video and try it on your own, then you can see what the answer is and listen to my explanation. But what I see is inside of these brackets, there's a lot of work to do. I'll keep the 2 on the outside for right now. And we're going to have the ln of x divided by x plus 2. And the minus means that the x plus 3 is also going to go to the denominator. And then this 2 is going to distribute to everything on the inside. So we're going to have the ln of x squared over x plus 2 squared times x plus 3 squared. Another thing I can do with this one to simplify it a little bit more is to rewrite it as x squared over. Since the x plus 2 and x plus 3 can be multiplied, we could have multiplied them first. So x plus 2 times the quantity x plus 3 would give us x squared plus 5x plus 6, and then that entire quantity would be squared. I think this red answer probably looks a little bit nicer. Next, we're looking to simplify this log. And unfortunately, these bases are different. We have log base 1/3 of 9 to the 2x. If these bases were the same, our answer would just be this exponent because they're in essence inverse operations of each other. But what we can do is we can rewrite this 9 to the 2x as 1/3 to some power, because then I can plug it back in there and I have a simple log to break down then. So my goal here is to figure out what is this exponent. 9 to the 2x is equal to 1/3 to what power? I'm going to create this temporary variable of w, and w is what I need to put in there. So as I look on the left, 9 to the 2x, well, that's going to be 3 squared to 2x. It looks a little bit closer to 1/3. The 2 times the 2x means this is 3 to the 4x on the left. And one more step in this one. 1/3, or 3, is 1/3 to the negative first to the 4x. So I broke it all the way down, so now I have this base of 1/3. And then if we multiply those together, we get negative 4x. It's equal to the right side, which is 1/3 to the w. W is what I wanted. And since these bases are the same, it means these exponents have to be the same. So w, our base on this, is going to be log base 1/3 of 1/3 to the negative 4x. Now as I look at these, log base 1/3 of 1/3, those are going to cancel out, so our answer is going to be negative 4x. So here's our next example. Our goal is to simplify this. They both have log base 6, which is nice, and we'll get to that in a little bit, but this 3 is going to become an exponent for that 2. So we have log base 6 of 20 over log base 6 of 2 to the 3rd. 2 to the 3rd power is 8. Next, I can't divide the 20 over 8. I can't subtract 20 minus 8. That's not what the properties of logs is about. If it was a log base 6 of 20 over 8, then I could expand it to log base 6 of 20 minus the log base 6 of 8. That's not what we have here. What we can do is rewrite the numerator using the change of base formula. It's the log of 20 over the log of 6. And the denominator we can write as the log of 8 over the log of 6. And then as I notice in the numerator and denominator, I can multiply the numerator by log of 6 multiply the denominator by log of 6, and that simplifies it a little bit at least. So we get the log of 20 over the log of 8. A little simpler than the red one because we have standard base of 20, but this is as simplified as it can get. Here's our next problem, and it's an exponential one with an exponent that's a log, which can look kind of messy. And maybe it doesn't make sense to you right away. Maybe you realize that these are inverse operations of each other. But when you're stuck, a good strategy is always to convert. So I'm going to say this entire problem is equal to y. I'm trying to evaluate this. So if I can solve for y, then I have what the answer is equal to, have it evaluated. Now this is in exponential form, so I'm going to convert this to log base 13. This is the 13 we're talking about, of y equals log base 13 of x. This y is what goes right here, and this is what goes on the other side. So I'm taking it from exponential form and putting it into log form. The good news here is, as I look on the left side and the right side, they both have log base 13. Since those are the same, that means that these, what we're taking the logs of, must be the same. So y equals x. Y stood for our answer, so the answer to this one is x. Anytime you see something like this, a log base a of x, the answer is going to be x, because these are inverse operations. This is a similar problem to the previous one. The only difference is the base of 25 and the base of 1/5 are different. If these bases were the same, then my answer would just be x. So what we're going to do is we're going to take that 25 and we want to turn it into an exponential problem that has a base of 1/5. So I'm going to say 25 is 1/5 to what power? So as I look at 25, I know that's 5 squared. And if I want that 5 squared to become 1/5, I'd have to do the inverse of it. So it would be 5 to the, figure that, 1/5 the negative 1 squared. So 1/5 to the negative 1 is 5. And then if I'm squaring that, then it's equivalent to the original. So this left side is 1/5 to the negative 2. The right side is 1/5 to the what power? So as I look at this now, 25 is equivalent to saying 1/5 to the negative 2. So I'll go back over here again then. This is 1/5 to the negative 2 log base 1/5 x. Now this negative 2 was from the 1/5, but since it's out in front of this log now, using those properties of logs, I know that it's going to become this exponent. So this would be 1/5 to the log base 1/5 of x to the negative 2. I notice now that this base of 1/5, this base of 1/5 are the same, so then they are inverse operations, and I can say that this answer is x to the negative 2. So here's our next problem. It's a lot like the previous one. So this is another time where I might encourage you to pause, try to do this problem on your own, and then compare answers. But what I see here is another exponential problem that has an exponent of a base, but the base of 9 and the base of 27 aren't the same. My goal here then is to get them to have the same base. I can't alter this log base 9 of all, so I want to take the 27 and rewrite it so that it has a base of 9. So I'm saying 27 is 9 to what power? I want to figure out what this base is, or what this exponent is, if I turn 27 into an exponential problem with 9 as its base. So 27, what I'm going to do first of all here is rewrite 27 so that it is 3 to the third, which is a good start. And then on this other side, I'm going to take the 9 and rewrite that as 3 squared, and there's still the w up here. The left side has a base of 3, the right side has a base of 3, so even though I wanted 27 to have a base of 9, I started it that way. I got them down to a common base of 3. Since they have the common base of 3, those two exponents are equal to each other. So now I can say these exponents, 3 and 2 w are equal to each other. If I divide both sides by 2, then my exponent is 3/2. In other words, the number 27 is equivalent to saying 9 to the 3/2. There was already up here this 2 log base 9 of x. I could have put the 2 on that exponent right away. I chose not to do that. Now I can see that these would have to multiply. 3/2 times 2 is 3, so it's 9 to the 3 log base 9 of x. Now I'll put that up there as the exponent. It's 9 to the log base 9 of x to the third. This 9 and that 9 are going to cancel each other out. They're inverse operations. So our simplified answer here is x to the third. Next example asks us to compute this. And I see this nice log base of 6 with a 36 and a square root of 6 in there. And I see between them there's not anything written, but it's implied that there's a multiplication sign. So what we're going to do is we're going to expand this. It's log base 6 of 36, log base 6 of the square root of 6. And since these are multiplied inside of this log, it means we're going to add them right here. And now as I look at them individually, there's a longer way to do this. I set this equal to y, put it into exponential form, but hopefully you're getting good at identifying these. We're saying 6 to what power is 36? I know 6 squared is 36. And then 6 to what power is the square root of 6? This is 1/2. When you're taking the square root, you have the 1/2 power. So each of those simplifies down to a number. Now we can add them together. So our answer is going to be 2.5, 2.5, 5/2, all the same thing. When we're looking to simplify, we have to get these combined together. The difficult thing in this one is that the number 4 doesn't have a log, much less a log base 2 like the second one. So what we're going to have to do is we're going to have to convert this one so that it looks more like the other problem. And what I'm thinking here is 4 is log base 2 of what number? Well, 2 to the 4th is 16. So if I said, what is log base 2 of 16? 2 what power is 16? It's 4. So these two things are equivalent to each other. I just took my log base 2, 2 to the 4th, to get that 16 right there. Keep log base 2 of x the same. And the reason why I converted 4 into this form is now that as I look at these two, they both have log base 2, which means I can condense them together. The plus sign between the logs means we multiply what's on the inside, and we get log base 2 of 16x. And here's our last problem. We need to get these combined together, and this might be another good time to pause and try to do this one on your own, knowing that we have a number and a log with a base on it we need to get combined together. What I see here is this 3 needs to be rewritten as log base 4, just like this log base 4 of something. Well, 4 to the 3rd power is 64. In other words, log base 4 of 64 is 3. 4 to the 3rd equals 64, so this is equivalent to 3. This 5 for the second part is going to become an exponent. It's going to kick up there. Now that they have log base 4, I can get them combined into one single log. 64, the minus sign means divide, so we're dividing that by x to the 5th. And there is our log.